Hello, thank you for joining us for the Beaumont District Noise Barrier Workshop. My name is Octavio Sainz, and I would like to welcome you and also thank you for watching this virtual noise workshop that was shared with the public starting on Tuesday, June 15, 2021. I am the TxDOT Public Information Officer for the FAR District, but I'm serving as your presenter on behalf of the Beaumont District. I will be presenting a brief summary of the proposed IH-10 US 69 interchange project and will discuss the project's need and purpose and a description of the proposed noise barrier. We appreciate your interest in this noise barrier workshop and welcome you. The purpose of this noise workshop is to inform you about a noise barrier recommended near your neighborhood and to solicit your viewpoint as a resident adjacent or benefiting from the proposed barrier. To begin, I would like to talk a little bit about the project. TxDOT and the Federal Highway Administration propose to reconstruct and expand IH-10 and US 69 where they converge in the city of Beaumont in Jefferson County. The proposed project would widen the existing I-10 from Hollywood Overpass east to 7th Street. What is our goal for today? First, to provide you with a general overview of our traffic noise analysis and criteria used to develop our preliminary noise barrier recommendation. Next, to explain your role in making your voice be heard. After learning about the proposed noise barrier, you'll be invited to cast a vote for or against the noise barrier. Details regarding the aesthetic and landscape design elements as they pertain to the noise barrier are part of this presentation. We want to provide you with all the details necessary to make an informed decision in order to vote for or against the proposed noise barrier. I will start out with some general information regarding sound and noise. Then I will describe how the traffic noise analysis and abatement process was conducted for this project. Then I'll describe the proposed noise barriers. The purpose of the project is to alleviate congestion, to provide a more reliable transportation and evacuation route, to enhance connectivity and mobility, and to address safety. The two I-10 interchanges with US 69 and Beaumont are a critical part of the strategic freight network and hurricane evacuation capacity in southeast Texas. Tonight's presentation will focus only on the Eastex interchange. This slide shows where the proposed noise barrier 3 would be located. Barrier 3 will be constructed in two segments between 8th Street to 10th Street and allow for through traffic at 9th Street. Let us discuss some general information regarding sound and noise. Then I will describe how the traffic noise analysis and abatement process was conducted for the project. We will also talk about the proposed noise barriers. The project team will be available at 6 p.m. on June 17th in a live noise barrier workshop to answer any questions that you may have. What is sound? Sounds are vibrations traveling through the air as sound waves. Noise, on the other hand, is unwanted sound. Cars and trucks generate noise. This traffic noise is produced by the movement of engines, the vibration of exhaust systems, and the friction of tires against the roadway. The loudness of noise from traffic depends on the road surface type, the amount of traffic, how fast the traffic is moving, and the number and type of vehicles traveling on the road. For example, 18-wheeler trucks with their bigger engines and many tires produce more sound than the typical 4-door passenger car. In general, the more traffic on the road and the faster the traffic is moving, the louder it will be for a person near the road. Additionally, if you are within the line of sight of a highway, it is going to be louder than if you cannot directly see the road because sound is loudest when it travels in a straight path. Sound waves move outward from a source in all directions. When there are no objects in between the source and your ear, noise will travel in a direct path. However, sound can be reduced by placing a solid object or barrier, such as a wall, in between the source and the receiver. The location and height of a barrier can affect the amount of noise that is reduced. Highway traffic noise is often blocked by buildings. Tall fences can reduce sound levels, but no barrier can completely block all traffic noise. Topography also affects highway traffic noise levels. When the highway is either higher or lower than the receiver, overall noise levels are reduced. In both these cases, the sound waves have a longer path to travel. So how does TxDOT evaluate traffic noise and noise abatement for highway projects? The Federal Highway Administration, or FHWA, requires that we conduct noise studies when federal funds are utilized and when adding capacity on existing highways which may have an increased effect on noise. The purpose of our noise study is to investigate the impact that the I-10 US 69 Interchanges project has on the nearby outdoor areas frequently used by people. The noise analysis for this project was performed in accordance with TxDOT's Guidelines for Analysis and Abatement of Roadway Traffic Noise and Reasonable Cost Proposal for 2018 Noise Policy. The TxDOT guidelines have been approved by the FHWA. The Federal Highway Traffic Noise Modeling software, known as Traffic Noise Model or TNM, was used to calculate the existing and predicted future traffic noise levels along the roadway project. A traffic noise analysis is a multi-step process. A noise workshop is usually one of the last steps in this process before the final engineering plans are approved and the project is constructed. The noise analysis process includes identifying noise receivers, modeling noise levels, identifying potential noise impacts, considering abatement for noise impacts, and finally, talking to the benefited residents and owners adjacent to the road about the results of the noise analysis and soliciting the vote of property owners at a noise workshop. The purpose of a noise analysis is to determine whether traffic sounds from a highway will have an impact on nearby outdoor areas frequently used by people. These areas are called receiver locations or receivers. Some examples of receivers include residential backyards, playgrounds, and schools. After identifying receivers, a noise analyst determines existing and future noise levels at these locations. Then, based on the predicted noise levels and criteria, the noise analyst identifies possible noise impacts and looks at ways to reduce those impacts. The traffic noise analysis is performed by using an approved computer modeling software called Traffic Noise Model version 2.5. The computer model requires the analyst to enter noise receiver locations, the amount of traffic, and traffic type. Traffic type is a percentage of cars, medium trucks, and heavy trucks. The model also considers how fast the traffic is moving, the roadway design, and surrounding terrain features. Traffic noise is modeled for both the existing traffic and roadway conditions and for future traffic projections and the proposed highway design. So how do we determine if there will be a traffic noise impact? We use noise abatement criteria established by the Federal Highway Administration. The noise abatement criteria, or NAC, for residential land use is 67 decibels. A decibel is a measure of the loudness of sound. There are two types of noise impacts. An absolute impact is when the predicted noise level at a receiver approaches, equals, or exceeds the noise abatement criteria value. For residential properties, an impact would occur if the predicted noise level is 66 decibels or more. A relative noise impact is when the predicted noise level is substantially higher. This is when the future noise level is more than 10 decibels higher than the existing noise levels. If there is a noise impact identified, then the next step is to consider abatement measures. Abatement measures are actions that could lower the noise level. These include traffic management, alteration of alignment, acquisition of buffer zones, insulation of public buildings, and finally, the construction of noise barriers. Construction of noise barriers has been determined to be the best solution for this project. What is a noise barrier? Noise barriers are solid walls or barriers that are constructed between the highway and people in order to help reduce roadway noise levels. Noise barriers can reduce noise levels but do not completely block all noise. However, a noise barrier cannot be proposed unless the barrier is determined to be both feasible and reasonable. What makes an abatement measure feasible? Feasibility first means that a noise barrier can actually be built in a location, given site constraints such as topography, driveway access, drainage, utilities, and maintenance. Feasibility also means that the noise barrier must provide a substantial reduction in noise levels. A substantial reduction is defined as a reduction of at least 5 decibels at greater than 50% of the first row impacted receivers. The second criteria is that a noise abatement measure should be reasonable. There are two measures of Reasonableness. First, the baseline cost of a barrier is $25,000 per benefited receiver. Second, a proposed barrier has to meet a noise reduction design goal to provide a 7 decibel decrease for at least one impacted receiver. For this project, noise levels would approach, equal, or exceed the level at which the Federal Highway Administration would consider noise abatement. As a result, noise barriers were evaluated at the I-10 and US 69 intersection. It was determined that the construction of noise barriers in 4 locations along I-10 and US 69 could provide feasible and reasonable traffic noise abatement for this project. In this presentation, we're discussing Barrier 3 along I-10. This slide shows a preliminary layout of Barrier 3. Barrier 3 would be in 2 segments. The entire barrier, including both segments, will be 1,311 feet in length and 18 feet tall. It would be located on the I-10 frontage road from 8th Street to 10th Street. To show you what the proposed noise barriers might look like, here are some examples. The top 2 photos show noise barriers in San Antonio and Corpus Christi. The bottom 2 photos show noise barriers in Austin. Noise barriers are intended to provide positive aspects to neighborhoods, but there are some negative impacts that can occur as well. Noise barriers are designed to reduce the traffic noise and are normally well received. However, they can also result in restricted views, feelings of confinement, can affect sunlight, and in some instances limit access to nearby streets. Noise barriers may also provide a surface for graffiti. Finally, it's important that you know that a noise barrier will not eliminate all noise. There will still be noise, but it would be decreased. So, who can vote? To be eligible to vote, you must be the owner or resident of a property that touches a right-of-way line near where a barrier is proposed. Only 1 vote is allowed per property. Some residents that are not directly adjacent to the right-of-way line have also been identified by the noise model. Those persons can also vote. Not all votes are counted equally. A weighing system is applied based on owner occupancy. For owner-occupied dwelling units, the property owner's response counts as the 1 vote. If multiple ballots are received from multiple owners of the same unit, for instance, a husband and wife each submit a ballot, they are collectively counted as 1 vote. For non-owner-occupied dwelling units, a response from the resident or renter counts as 10% of the vote, and a response from the owner counts as 90% of the unit's vote. You may only vote for or against the proposed barrier nearest your property. The decision to construct a particular barrier is based on a simple majority vote. For example, if there are 30 property owners eligible to vote, then a majority is 16 votes. So, if 16 or more owners vote in favor of the barrier, then the noise barrier will be built for that location. A majority of votes against the barrier would mean that a barrier would not be built at that location. It is important to note that the decision will be based on a majority of votes received. Each proposed barrier is considered separately during the voting process. There are 3 proposed barriers along FM 2818. Some areas may get a barrier and some may not. It all depends on how the adjacent property owners vote. It is important that we receive your vote. Now, I would like to direct your attention to the noise ballot. In the letter you received from TxDOT, you will find a ballot in both English and Spanish. Please know that eligible voters are those that own or rent property adjacent to the right-of-way near the proposed noise barrier, or those that were identified to benefit from the barrier. So that we can count your votes correctly, please provide your full name, address, and telephone number. Please vote for if you are in favor of a noise barrier near your neighborhood, or against if you do not want a noise barrier constructed. There is also a place on the noise ballot to provide comments if you choose to do so. Please complete a noise ballot to record your vote and send it in using the pre-addressed stamped envelope that was provided with your workshop notice. TxDOT requests that all the completed ballots be postmarked no later than Wednesday, June 30th. If we do not receive ballots from a majority of property owners for each barrier by that date, we are required to send out a second round of letters and ballots to property owners that did not respond. After the second round, TxDOT will make a decision to build or not build each of the proposed noise barriers based on the ballots that were received. All property owners will be notified of the final decision by mail when a majority vote is received. Following the Friday, July 2, 2021 deadline for ballot submittal, ballots submitted by the benefited residents and owners adjacent to the proposed noise barrier would be tallied. If at least 51% of the ballots tallied show support for the construction of the proposed noise barrier, the barrier would be planned to be constructed as part of the SH69 Interchange Improvement Project. Construction of the noise barrier is anticipated to begin in 2021 if approved by majority vote. This concludes tonight's TxDOT Barrier Workshop presentation. Thank you for your time. And by the way, should you have additional questions, do not hesitate to contact Benjamin King. His information is on this slide. Thank you.